Okay, so in this scenario, there are two prisoners who have just been caught for their crimes, and the police have some evidence on the crimes that they've done. Each prisoner is then put into a separate room, and they have two options, to either confess or to not confess. And the payoff, which you can see in the payoff matrix here, is that by each of them confessing, they will get 5 years in prison. Each of them not confessing will get 4. And if one confesses and one doesn't confess, vice versa, no matter what, you will either have 10 years or 3 years, some combination depending on which prisoner you are in the situation. So in order to determine whether or not they have a dominant strategy, let's look at prisoner 1 first. So if prisoner 1 is to confess, prisoner 2 has two options. They can either confess as well, or they don't confess at all. If prisoner 1 is to confess and prisoner 2 confesses, prisoner 2 is going to get 5 years. But if prisoner 2 doesn't confess, they get 10 years. So in a situation wherein prisoner 1 confesses, it makes the most sense for prisoner 2 to also confess. If you do the same thing with not confessing for prisoner 1, you come up with the result that prisoner 2 is yet again going to confess either way, because 3 years is less than 4 years. So in a situation with prisoner 1 kind of being like the determinant, prisoner 2, no matter what happens, no matter what choice prisoner 1 makes, is always going to confess, because it will always be less than if they choose not to confess. And you can do this vice versa, so you can do this the other way with prisoner 1 as well. So if prisoner 2 decides that they want to confess, prisoner 1 has two options, confess or not confess. The same numbers apply. Either way, prisoner 1 is also going to confess, no matter what prisoner 2 chooses, because no matter what the scenario is, 5 years is going to be less. So in this situation, prisoner 1's dominant strategy is to confess, and prisoner 2's dominant strategy is also to confess, because as it says here, it's best for them to confess regardless of what the other player chooses. Regardless of whether or not player 1 confesses or not confesses, player 2 will always pick confess, and vice versa. So with that in mind, you also can determine that this box here is what we call our Nash equilibrium.